There is a photograph taken by the James Webb Space Telescope that contains thousands of galaxies, spirals, smudges, faint arcs of light bent by gravity, and scattered through it, almost too small to notice, are dozens of tiny red dots. For 3 years, nobody could tell you what they were. They appear in nearly every deep field image Webb has ever taken. They are everywhere in the early universe. And by the present day, they are simply gone. Whatever they are, they existed, in enormous numbers, and then they stopped. Now hold on one of them. Because one of those dots should not be able to exist. It is roughly the size of our entire solar system. Not a star, not a solar system with planets in it, but a single glowing object stretching from where our sun is to somewhere out past the orbit of Neptune. And it is putting out around 100 billion times more energy than any star of any size is physically capable of producing. That is not an exaggeration for effect. That is the measured number. There is a hard ceiling on how much light nuclear fusion can generate, set by physics, and this object is not near that ceiling. It is 100 billion times past it. And when astronomers looked at the light coming off it, they found something else. Almost no heavy elements. Practically nothing except hydrogen and helium. And a drop in the spectrum, a place where the light just stops, that is the deepest such drop ever recorded in any object anywhere in the universe. Something the size of a solar system. Something too bright to be a star. Something made of almost nothing but the two lightest elements that exist. On the 12th of August, 2026, a team led by Mitt published a paper in the journal Nature saying they think they finally know what it is. And their answer is that it is not a star, and it is not a galaxy, and it is not a quasar. It is a kind of object nobody had ever seen before. They are calling it a black hole star. The object has a name now. MOM-BH star-1. Here is what I want you to stay for. First, the color red fooled everybody for 3 years, and the reason it fooled them is genuinely clever and genuinely embarrassing. Second, once you rule out fusion, there is only one thing in the universe that can power something this bright, and putting it in the middle creates an object that has no business holding together. And third, if this model is right, then the enormous black hole sitting at the center of our own galaxy, the one our sun has been orbiting for 4.5 billion years, may have started out as one of these. I am going to walk you through exactly how they got there. Subscribe if you want more of these. Real papers, real data, and none of the exaggeration. Go back to 2022. The James Webb Space Telescope had just started returning images, and it was doing something no telescope had ever done. It was seeing the universe in infrared, deeply, and that meant it was seeing further back in time than anything before it. The very first deep field images came back, and almost immediately astronomers noticed something odd. Sprinkled across them were these small, extremely red, extremely compact points of light. They were not resolved into shapes. They were not obviously galaxies. They were just dots. Somebody called them little red dots, and the name stuck, which tells you something about how little anyone understood them. Here is what made them strange, straight away. If you plot the light coming from one of these objects across different wavelengths, you get a shape astronomers describe as a V. The light is relatively bright in the ultraviolet, then it dips down, and then it climbs steeply into the red. Nothing about that shape matched anything in the existing catalog. There were candidate explanations, and for 3 years people argued about all of them. Maybe they were extremely massive galaxies, packed with stars, that had somehow assembled far earlier than any model said was possible. That explanation had a serious problem. If you took the brightness at face value and worked out how many stars you would need to produce it, you got galaxies so massive, so early, that they would break the standard model of how the universe assembled itself. There simply had not been enough time for that much matter to gather in one place. That problem became known informally as the impossible early galaxy problem. And it was not a small thing. It suggested either the objects were being misread or cosmology was wrong. Maybe instead they were active galactic nuclei. Feeding black holes at the centers of ordinary galaxies, the sort of thing we have known about for decades. But that had problems too. Objects like that are usually loud in X-rays, and these were almost silent. They usually show warm dust glowing in the mid-infrared, and these did not. They usually flicker in brightness as material falls in unevenly, and most of these barely varied at all. So they were not quite galaxies, and they were not quite the black holes we knew about. And there were an enormous number of them, and then at some point in cosmic history, they vanished. This is where the team comes in. Rohan Naidu at MIT's Kavli Institute for Astrophysics and Space Research, working with Robert Simcoe, the institute's director, and their collaborators, were running a web survey looking for the earliest galaxies they could find. They had given the survey a name that turned out to be more appropriate than they expected. They called it Mirage or Miracle. The logic in the name is this. When you find something that looks like an impossibly bright galaxy at an impossibly early time, you have two options. Either it is a miracle, and the universe built something faster than we thought possible, or it is a mirage, and you are being fooled by what you are looking at. While they were going through Webb's images, picking out targets, they found a dot that was redder and brighter than anything else on the list. Now, the first assumption anyone makes about something red in space is dust. There is a good reason for that assumption. Dust in space is made of tiny grains of carbon and silicates, and those grains scatter blue light much more effectively than red light. So when you look at an object through a veil of dust, the blue gets scattered away and the red comes through, and the object appears redder than it actually is. You have seen this happen in your own sky. When wildfire smoke drifts across a city, the sun turns deep orange and then red. The sun has not changed. The path the light took to reach you has changed. Simcoe used exactly this comparison, pointing to the smoke that made the sky over Boston glow red not long ago. So for 3 years, the working assumption for a lot of people was straightforward. These dots are red because they are dusty. Behind the dust, there is something ordinary. But when the team looked closely, the light was not behaving the way dusty light behaves. Dust reddens things in a particular, predictable pattern across wavelengths, and this object was not following it. And then there was the other feature, the one that ended up being the key to everything. Below a certain wavelength, the light from this object did not just dim, it fell off a cliff. Astronomers call this a Balmer break. And I want to explain it properly because the entire discovery turns on it. Hydrogen atoms absorb light at very specific energies, and one particular family of those absorptions clusters together in a narrow band. If you have a thick layer of hydrogen sitting in front of a light source, and that hydrogen is in the right state, it will absorb almost everything on one side of that band and let almost everything through on the other side. The result, when you plot it out, is a step, a sharp edge in the spectrum. We see this in ordinary stars all the time. Vega, one of the brightest stars in the northern sky, shows this pattern clearly. It comes from the outer layers of the star, the atmosphere, absorbing its own light on the way out. Astronomers have used the size of that step for decades to work out how old a population of stars is. The step in this object was the deepest ever observed. Not the deepest for its type, the deepest in anything, ever. And that is a genuine problem, because there is a limit to how deep stars can make it. You can stack up as many stars as you like, of whatever ages you like, and there is a maximum step you can produce. This object was well beyond it. Whatever was absorbing that light, it was not the atmospheres of ordinary stars. Then came the detail that finished off the dust explanation for good. The light showed almost no trace of anything heavier than helium, no carbon, no oxygen, no silicon. Just the raw material the universe started with. Sit with what that means for a second. Dust is made of heavy elements, carbon and silicates. Those elements have to be manufactured inside stars and then thrown out into space when those stars die. If an object contains essentially no heavy elements, then it cannot contain any meaningful amount of dust, because the ingredients for dust do not exist there yet. So the object was red, and there was no dust available to make it red. The dust explanation had eaten itself, which left the team with a very specific and very awkward question. Can you make something look this red using nothing but hydrogen? They ran simulations to find out, and the answer, to their own surprise, was yes, but only under one condition. The hydrogen has to be extraordinarily dense, not nebula dense, interstellar gas clouds, the beautiful glowing structures in Hubble photographs, are so thin that by laboratory standards they are a very good vacuum. That is not what this requires. This requires hydrogen packed so tightly that it stops behaving like a cloud and starts behaving like a surface. Dense enough that light cannot pass straight through. Dense enough that it absorbs and re-emits and absorbs again so that what escapes has been completely reprocessed on the way out. In other words, it stops being a nebula and starts being something much more like the outer layer of a star, and that immediately explains two of the three mysteries. It explains the impossible Balmer break, because you now have an absorbing layer far thicker than any stellar atmosphere. And it explains the red color without needing a single grain of dust. But it does not explain the brightness. It makes the brightness worse, because now you have something that behaves like the surface of a star, and it is 100 billion times brighter than a star can be. Nuclear fusion is what powers every star in the sky. Hydrogen fuses into helium in the core, and that reaction releases energy, and that energy works its way outward and eventually leaves as light. It is a spectacular process, and it is also a limited one. There is a ceiling. Make a star too massive, and it does not get proportionally brighter. It becomes unstable and tears itself apart. So fusion is off the table. And once you take fusion off the table, the list of things in the universe that can produce energy on this scale gets very short. There is really only one item on it. Matter falling into a black hole is the most efficient energy conversion process known in nature. As gas spirals inward, it heats through friction and compression until it glows, and the fraction of its mass that gets converted into light is far higher than anything fusion can manage. This is why quasars, which are feeding black holes at the centers of distant galaxies, are the brightest sustained objects in the universe. So the team put a black hole in the middle of their simulated hydrogen cocoon and started varying its mass to see what would match. They found their answer at around 100,000 times the mass of the Sun, and that gives you the object. A black hole of about 100,000 solar masses, wrapped in a dense envelope of nearly pure hydrogen that stretches out roughly to the scale of our solar system. The black hole does the job that fusion does in an ordinary star. It sits at the center and provides the power. The hydrogen envelope does the job that a stellar surface does. It absorbs the energy, holds it, and releases it as the reddened, star-like light that Webb detected. That is a black hole star. A black hole wearing a star as clothing. And I want to be precise about how unusual that arrangement is, because it is easy to nod along without noticing. A normal feeding black hole builds a flat disk around itself, material spirals in through a pancake, and enormous amounts of light escape in every other direction. That is a quasar. It is bright. It is variable. It is loud in X-rays. This is not that. Here the black hole is buried. The gas is not organized into a thin disk. It is a thick, roughly spherical shell, and it is so opaque that the black hole's light cannot get out directly. Everything we see has been absorbed and re-emitted by the envelope first, which suddenly explains all the things that made little red dots so confusing. Why they are quiet in X-rays, why they do not flicker much, why there is no warm dust glowing in the mid-infrared. The black hole is not hidden behind dust. It is hidden inside a hydrogen atmosphere of its own making. The team named it MOM-BH *1 after the survey and after the object type. The number 1 is doing deliberate work in that name. They are saying they expect there to be others. And this is where it stops being about one strange dot. Naidu's position is that every little red dot Webb has found is consistent with being one of these. What makes this particular object special is not that it is different from the others. It is that it is so bright that it completely outshines whatever galaxy it sits in. With the others, you are seeing a black hole star mixed in with starlight from its host. With this one, you are seeing black hole starlight and essentially nothing else. It is the clean sample. Now put that together with the thing I mentioned at the very start. Little red dots are everywhere in the early universe, and they are gone today. Not rare today. Gone If black hole stars explain little red dots, then this is not a rare freak object. It is a phase, a stage that a huge number of black holes passed through when the universe was young and then grew out of. And that leads somewhere uncomfortable and rather wonderful. The Milky Way has a supermassive black hole at its center, 4 million times the mass of the Sun. Our entire solar system orbits it once every 230 million years or so. Almost every large galaxy has one, and where they came from has been an open question for decades. They are too big to have grown from collapsed stars in the time available, and nobody has been able to explain how they got so large so fast. If the black hole star model holds up, that gap starts to close. This becomes the missing early stage, a route for making massive black holes quickly, and one that appears to have been extremely common, which would mean that the object at the center of our own galaxy, the one everything you have ever known has been quietly circling, may have spent its youth buried inside a glowing hydrogen envelope the size of a solar system. There is a further implication that the team has raised, and it is bigger still. An object like this pumps enormous amounts of energy into the gas around it. Gas that is being heated and pushed cannot easily collapse into new stars. So these things may have acted as regulators in the early universe, helping decide when and where stars could form at all. And everything that follows from star formation follows from that. Planets, chemistry, us, now, the honest part, which the title of this video did not give you. Scientists are not baffled by this object. That framing is what you will see in a lot of headlines, and it is wrong, and the real situation is more interesting. What actually happened is that for 3 years there was no model that could account for what Webb was seeing, and now there is one, and it fits well. That is not confusion. That is science working. But it is one model, and it should be treated like one. It is a scenario that reproduces the observations, which is not the same as a scenario that has been confirmed. There are real open questions, and the people who publish this are the ones asking them loudest. How does something like this form in the first place? How does the envelope survive? The black hole in the middle is eating the gas around it, so there has to be some mechanism continually resupplying the envelope, or the whole structure should collapse in on itself fairly quickly. Nobody has that mechanism worked out yet. There is also supporting evidence from a completely separate direction, which matters more than a single result on its own. A different team, led by Anna de Graaf at the Max Planck Institute for Astronomy, studied another extreme little red dot, one they nicknamed the Cliff for the sheer steepness of its spectral drop. They arrived independently at the same conclusion. The absorption is coming from dense gas, not from old stars. Two groups, different objects, different surveys, same answer. More Webb observations targeting these objects have already been approved. Within a year or two, there should be data good enough to either strengthen this or break it. So, what did James Webb actually find? Not a mystery nobody can explain. It found a red dot so extreme that it forced astronomers to invent a new category of object to hold it. Something the size of a solar system, powered by a black hole 100,000 times the mass of the Sun, wrapped in a shell of pure hydrogen dense enough to behave like the surface of a star. A thing that is neither a star nor a quasar, and that appears to have been common in the early universe and is now completely extinct. And here is the part I keep coming back to. We did not find it because we went looking for it. Nobody predicted black hole stars. There was no theory waiting for confirmation. A team went hunting for early galaxies, noticed a dot that was slightly too red, and pulled on it until an entirely new class of object fell out, which raises the obvious question. These have been sitting in Webb's images since 2022 in plain view, in nearly every deep field, and we spent 3 years calling them dots because we had no better word. That is with our best telescope, pointed at the best studied patches of sky we have. So what else is in those images that we are currently walking straight past? I want to know which part of this you find hardest to accept. That an object the size of a solar system can hold together at all? Or that something this common, this recently, went completely unexplained? Tell me in the comments. If you want more of these, real papers, real data, and the parts where scientists say plainly that they do not know yet, subscribe. Next time, we are going back to the early universe for something that should not have had time to exist. Thanks for watching.